Now let us look at the pressure volume diagram. So here you have pressure in the y-axis and specific volume in the x-axis. So what we are doing is that initially you have this liquid here. It is kept at 1 megapascal and temperature 150 degree Celsius. So you have various weights above this piston, so you can remove this weight one by one. For when you remove this weight, the gas will be pushed outward. That means the pressure is getting reduced. Pressure is reduced. If you remove this piston completely, the pressure will gets completely reduced. Initially the pressure was at 1 megapascal. So when you remove this weight, the pressure here gets reduced and temperature will also change. Temperature will also get reduced. So you can supply heat to maintain this temperature as constant. You can maintain this temperature as constant. You can reduce the pressure. We are doing this at constant pressure. Earlier we have done this heating at constant pressure. Now we are doing at constant temperature. That means temperature here is kept constant. Okay, you can see, let us start from this point. So when you remove this weight and supply heat, if you keep the temperature constant, as the pressure drops, you can see that when the pressure drops, you can see that specific volume increases. A specific volume of this liquid increases. So when the pressure comes down, volume will increase. You can see that here in dotted line. So it will reach a saturated point. It will reach a saturated point here. And after that, you can see that there is a phase change process. That means pressure will remain constant. That is the saturation pressure. And specific volume keeps on increasing. That means this liquid is getting converted to vapor. Okay. From this state, when you reduce the pressure and keeping the temperature constant at T1, you can see that specific volume increases. It will become vapor. So if you are doing this at a temperature greater than that of T1, you can get a line like this. Okay, these are the lines, PV diagram. So you can draw various lines and obtain all the saturated points here. And if you connect all these saturated points, you can get a dome shape here. This is the dome. And the top of the dome, you have the critical point. Okay, at this point, saturated liquid and saturated vapor point coincide each other.